Hi, this is Ethan Kim from Chips&Media. In this talk, I will introduce our leading-edge video codec IPs, including WAVE517 and WAVE524. I hope this talk can help the SoC architects and designers to include video codec functionality in the SoC to the right selection. First of all, I will introduce the video codec briefly. What is video codec? Codec is the abbreviation of the coder and decoder. An encoder means a device to compression something. Meanwhile, the decoder decompresses the compressed thing. In this case, encoder will compress the video. Why should we compress the video? If we don't use compression, it will require about 1.4 terabyte per second to sense or store 4K 60 frames per second video. In general, it is impossible to store or send digital video without compression. By using video codec, we can enjoy 4K 16 frames per second video from YouTube or Netflix using under the 20 megabps network. In other words, 2.5 megabytes per second. It compresses about 600 times. In these days, video traffic is rapidly increased. From the many reports and studies, video traffic takes about 75% of all internet traffic in 2017. And it takes more than 8% in this COVID pandemic era. Thus, more and more efficient video codec standards are developed. There are various video codec standards in the market. It is not easy to categorize the video codec standards. However, we can divide it by using generally supported resolution. From the MPEG-1 and MPEG-2 for DTV to ABS Plus and VP8, we call them legacy codecs. They are supporting up to full HD resolution. In the case of HVC from MPEG ISO, ABS2 from China, and VP9 and AV1 from Google and AOM, they support up to UHD resolution. And we can say it as a modern video codec standards. Chips&Media support legacy video codec standards using Codec products, and we support modern video codec standards using the WAVE series. In this talk, we will focus on the WAVE series. The WAVE series is the video codec platform in Chips&Media to support modern video codec standards. The WAVE architecture is scale-up architecture to meet the various performance and cost requirements in the market. By attaching more acceleration core, named V core, we can give a more powerful performance. Moreover, it is hybrid hardware and software architecture to balance performance and programmability. All the Chips&Media video IPs are state-proof. It means all the required operations, including skill sequence, frame, tile, and slice level, are performed in VPU. Thus, it shows an extremely low CPU load because it required operation in hosts are sending commands and getting the results only. Moreover, it adopts command queue architecture, which can queue commands ahead to minimize host CPU intervention. Stateful feature and command queue architecture are very attractive if multiple channels or high frame rate are required in the application because it allows loosely coupling operation between VPU and host CPU. This block shows an example of the WAVE architecture. It is composed of vCPU and vCore. Each vCore can have a post-processing unit based on the customer's need. The vCPU is a kind of programmable core with passing and entropy accelerators. It performs a high-level operation and schedules and allocates all the tasks for video codec processing. It also takes charge of communicating with host processor. The vCore is an acceleration core for video codec. The vCore has a simple control core called BPU, a bit processing unit, and a video codec processing pipeline called VCE, a video codec engine. It also has a post-processing unit to support output interfacing and post-processing. The WAVE series is categorized by performance of vCore and supported codec standards. Each series is composed of encoders, decoders, and codec IPs. The WAVE4 series can support HVC and WAVE9, and it supports 4K 60 frames per second using a single core. Meanwhile, the WAVE5 series, the latest released series, can support HVC, AVC, AVS2, WAVE9, and AV1. It supports 4K 60 frames per second using a single core. We plan to develop the WAVE6 series as a next generation platform that can support leading edge video codec standards such as WAVC, AVS3, or AVS2. As I mentioned previously, each series has encoder, decoder, and codec video IP cores. This chart shows the main product within WAVE5 series. In this talk, I will introduce two leading-edge video codec solutions, WAVE517 decoder and WAVE524 encoder. The WAVE517 is one of the first multi-format decoder to support almost all modern video codec standards, including AV1. It supports HVC, AVC, AVS2, WAVE9, and AV1 standards, and it can support 4K p 60 frames per second at 450 MHz operating frequency. Even there is high burst latency. The maximum resolution for decoding is 8K. As I mentioned, the performance can be increased by attaching more vCores. It has many useful design features, and almost all the features are applied to the encoder also. I'll share more details later in this talk. The WAVE517 can run 32 decoder instances simultaneously. In other words, up to 32 channels can be supported. The post-processing unit can be customized for the interface. Basically, it generates linear output with a long bursting size. On the fly downscaler in the post-processing unit can give better memory bandwidth than memory-to-memory downscaler. It can also have third-party frame buffer compression interface such as AFBC for ARM Mali GPU or DPU, and PVRIC for Imagination GPU or DPU. The WAVE517 decoder has error resiliency. If the stream has an error, VPU detects the error and tries to conceal the error, then report it to the host. The WAVE517 configures the supported video codec standards, features, and performance based on the market need. There are some pre-configured decoder IPs as shown in the figure. It also has a dual-core version named WAVE517, which can support 8K 60 frames per second in advanced processing node. You can find the supported profiles and level for each video codec standard in the table also. The WAVE524 is one of the first multi-codec encoder including AV1. This encoder supports HVC, AVC, and AV1. It supports 4K 60 frames per second at 500 MHz operating frequency, even there is high burst latency. The maximum resolution for encoding is 8K also. WAVE524 also can run 32 encoder instances simultaneously. The encoder also has some tools to improve image quality, such as background detection, custom Q matrix, and so on. It has a preprocessor to support various pixel formats by using bit depth conversion and chroma format conversion. Just like decoders, the WAVE524 can configure the supported video codec standards, features, and performance based on the market needs. There are some pre-configured encoder IPs as shown in the figure. The WAVE521 encoder supports HVC and AVC. We prefer the low-cost version with L postfix. It supports 8-bit bit-depth and single reference frame for the low-cost market with acceptable image quality. Like decoders, it has dual-core version named WAVE524, which can support 8K 60 frames per second in advanced process node. In this section, I'll talk about some of the features supported. C-frame is Chips&Media proprietary lossless frame buffer compression technology for compressing reference buffers. It is carefully designed to meet required block size and the patterns in the motion compensation operation. The decompressor also has a motion compensation cache inside the block to maximize efficiency. In our experiment using 4K sequence, it shows a more than 50% compression ratio on average. Chips&Media video codec IPs are designed to have burst latency tolerance for both read and write transactions. As you can see in the chart, it can perform real-time decoding even if all memory operation with about 1000 cycle latency. In the case of the encoder, it's slightly worse than that of the decoder. However, it can endure up to 500 cycle latency for all burst transactions. In our experiment, the latency on the write transactions affects encoder's performance, but the write transactions have to have such big latency for all write accesses in real SoC. In some applications, video processing latency is important. To lower the latency, our video codec IP also supports low latency features. The encoder has subframe synchronization and ultra-low latency mode to reduce latency. In the case of subframe synchronization, VPU can start encoding if one CTU or and below is available in the source frame. It uses dedicated interface to communicate with ISP or image feeders. Ultra-low latency operation mode is the encoder's operation mode to bypass the internal pipeline stage in frame level to chunk level. In this mode, the entropy engine can start using a small chunk of generated syntax from the encoding pipeline, and VPU updates the write pointer for the encoded bit stream for slide or chunk level. Thus, the host can send it as soon as possible it encoded by monitoring the registers. Decoder also has a similar feature. It updates write position of the decoded out frame buffer for every CTU rule. Thus, the host can start to display it as soon as possible it decoded. The WAVE5 encoders has a flexible rate control mechanism that can be tuned by the host. There are 3 levels of rate control. The first is the frame level buffer model. By using the buffer level from the previous frame, it controls the frame level QP. In the CTU level, almost all the same operation is performed, but it is less sensitive to keep the image quality. In the sub-CTU MB level, encoder adjusts QP based on the complexity of the block. It can improve the subjective quality of the image. Based on the rate control mechanism, the host can send the QP metrics and lambda metrics to tune the rate control and mode decision. By setting minimum and maximum QP value of the frame, our encoder can emulate CVBR rate algorithm. And by tuning on the HVS QP features with fixed QP operation, it can emulate CRF rate control. In the package, we deliver our proprietary API named VPU API for bare metal implementation. The API is a simple hardware abstraction layer to control functionalities in the VPU. It is easy to port to various platforms. For the Linux system, we have WAVE4L2 API, and it will be upstreamed in the near future. We also deliver the reference software as an example. By using the reference software, customer can easily port the VPO API to their applications. This picture shows multimedia frameworks based on the V4L2 driver. As you can see, CNN VPO API is wrapped in V4L2 layer, and it controls our WAVE5 VPO. In the Linux-based platform, user can easily integrate VPO using V4L2. Now, I will talk about roadmap for video products shortly. This picture shows our near-term roadmap for WAVE5 series. As you can see, WAVE517 is available. We are working toward to create AV1 encoder with a better image quality in WAVE524. The corrective codec product, named WAVE517C, will be available by the August of next year. Recently, the specification for VVC next video codec standards from MPEG is finalized. We are expecting VVC decoder by the end of next year and encoder by the third quarter of 2022. As it is proven in the market, Chips&Media always try to supply reliable video codec IPs to the partners. Thank you for your listening my talk. If you have question or comment, please contact using the email. Thank you.